Hello, hi everyone. Once again, welcome back to the channel. As a process of OWASP Docker Top 10, we are today going to discuss about D06, that is protect secrets. This is the sixth item in this particular series. Already we covered till D06. So here, protecting secrets is basically means securing a sensitive data within your Docker containers. That includes secrets like API keys, database passwords, tokens, or SSH keys that never be hard coded or exposed inside your images or any environment variables. If they're leaked, then that can will lead to a full system compromise also. Okay. So without further ado, let's discuss each and every point about this. First of all, what is a secret in a Docker? Okay. Basically, a secret is any sensitive information of your application that needs to be function. Okay. Basically, the secrets are a credentials or a keys that your application uses to connect to your services or to authenticate your users or to encrypt your data. If that particular secret is exposed, then that there is a high chances of exploitability instantly also. Okay, and these are the some examples for the secrets. Okay, passwords and authentication tokens, which is used to log into your services or APIs. API keys and certifications. This will grant you access to your external platforms or secure communication. And the next secret was database connection string. Basically, it will contains some credentials and host information for database access. The next one was private key and encryption keys, which is used for signing and decrypting or verifying the data. So that is the purpose of private key and encryption keys. So this was the example use case how those can be stored. Okay, like how it looks like basically. Okay, a database password. So this is the one example, and the API key. This is the one example. JWT token or secret. So basically, it is used to build a database connection strings. Okay. So yeah, these are the some things like what exactly the secret is, and moving further, where we are going to discuss why secrets need to be protected in a container. Okay, so uh, basically if you don't protect your secrets, then it will be like messy, right? So these are the things like that justifies why the secrets need to be protected. First one was containers are ephemeral and often shared. Containers are ephemeral in the sense like short-lived and frequently rebuilt or redeployed. If the secrets are embedded within a container, then they can be exposed during the image transfers or rebuild process. And images can be inspected by anyone with the access. So Docker images are very portable and it can be pulled by anyone if they have a proper access. If the secrets are baked within a Docker image, then there is a high chances of whenever the user extracted them, then uh, they can be accessible for that. Okay, so the next point was containers logs may be visible to operators. So whoever working in the operations stream, if the secrets are accidentally like printed in the logs, they become visible for anyone who access that particular container logging systems or some observability platforms that might be including the developers or admin teams or attackers also. Okay, and the fourth point was orchestration platforms store your container configurations. So platforms like Docker Swarm or Kubernetes that will store your configuration, I mean container configurations. If the secrets are like passed into the environment variables, they can be exposed in configuration files or directly in the dashboards. So that is the reason why the secrets need to be protected. And the key point here was unlike traditional servers, containers expose more attack surfaces for secrets. So proper protection is very much essential from day one itself. Okay, and not after a breach or attacker attacks. Okay. So moving further, where we are going to discuss what happens when the secrets are exposed. What can go wrong? Okay. So these are the some points which can go wrong. Complete database compromise and data theft. If attackers get access to your database credentials, they can steal, modify, or delete your sensitive data, and that will, I mean, that might be irreversible damage also can be happen. Okay, and unauthorized API access and resource abuse. Exposed APIs or some sensitive keys can be used to make unlimited requests, and that will consume a lot of like paid services also. So or else they can manipulate servers without detection. Okay, so identity theft and privilege escalations also happens. Secrets like tokens or some private keys can be used to impersonate users to escalate privileges and gain unauthorized access to critical systems, and financial losses and compliance violations. So leaked this, I mean, by leaking leaked secrets that will lead to a massive cloud bills as well as the service abuse, and as well as violation of certain regulatory standards like GDPR, HIPAA, PDI, DSS, like that. Okay, so here is a real impact. Yeah, I mean, based upon the some like data. Okay, a hard-coded AWS key in a Docker image led to a more than 100K plus US dollars in unexpected charges when attackers launched a cryptocurrency miners in a compromised account. Okay, so this can happen if we don't like secure the secrets properly. Okay, and moving further, where we will be discussing about some examples for secrets that you need to be protected or stored securely. Okay, here there are two categories like authentication as well as the keys and certificates. First of all, let's discuss about authentication. So these are the credentials that allows your application to log in or to authenticate with the other services. First one was database passwords, which is used to connect any databases like MySQL, PostgreSQL, MongoDB databases like that. Okay. And service account tokens, which is often used in a cloud platforms or else CI/CD tools like that. And OAuth client secrets, which is enables a secure login workflows and token exchange mechanism. So these are some examples for authentication secrets, and these are some examples for keys and certificates. That was the API keys like AWS, or it will basically grant you access to your cloud services and some any payment gateways or third-party APIs. SSL and TSL certificates, which is used to secure traffic between your clients and server communication. Encryption keys, it is also used to like encrypt and decrypt your sensitive data or sign-in tokens also. Okay, so these are some examples for secrets. And moving further, where we are going to see how secrets commonly get leaked. Okay, in the next slides, how it need to be protected. Okay, so hard coded into a Docker image or source code. First one. Okay, so whenever the secrets embedded within a Docker file or application code that can be extracted by anyone who have access to that particular image or repository, then that can be like leaked, right? And passed in the environment variables in a plain text manner. So by using in the environment variables -g flags or .env files that will expose your secrets in a container metadata and orchestration dashboards also. So that is also like how the secrets commonly leaked and stored in the configuration files within a particular containers. If the secrets are saved within a particular container in your configuration files, then they can be accessed by attackers or that can be leaked during a image inspection also. And the final point was logged accidentally in the application outputs. The debug logs or some error logs may uninterruptedly print CA secrets that will make them visible to your operators who are working on the logs. Okay, and that is the one point. And here the some key attack vectors. This was the example. I mean, these are some bad practices. Whenever we follow this, then these particular secrets are not secured properly. Okay, first of all was secrets in the Docker file by using env, like by using env argument, we are just storing the secret in the Docker file itself. Secrets in the Docker runtime. Okay, so we are running this particular Docker command, Docker run -e. By using -e argument, we are storing a API key. Okay, and the container name. Okay, so basically this will shows the kind of secret in the runtime. Okay, so this is also not a good practice, and that those are the some two different attack vectors. Okay, and here we are going to discuss how to identify if a secret are exposed. Okay, I think in this slide we are going to see how to identify, later how to prevent that. Okay, first point was we need to make sure to use the security scanners like a TruffleHog or GitLeaks, like that. Okay, basically these tools scans your code bases or images and some repositories for exposed secrets using a pattern matching mechanism or encryption analysis, and inspect your Docker images with your Docker history command. Basically, this particular Docker command reveals every layer of your images. If the secrets are added in a env or in the runtime also, it will still shows up but by this particular command. Check environment variables in running containers. So secrets passed via -e, earlier slide we have seen -e argument and API key, like that. So that will this particular environment variables, by checking this in your runtime, then it will be noted priorly, and we can handle them properly. Okay. And the fourth point was we review the application logs for accidental exposure. We need to make sure debug logs or error messages make if they may leak the secrets if the secrets may leak if the logs are like shown. Okay, so we need to make sure to sanitize them before, and always we need to make sure to audit the logs for sensitive data or any secrets. Here the quick check commands where this there are three commands. Let's go one by one. Inspect a Docker image. Okay, in a layer wise, it will inspect the Docker image with the help of Docker history and container name. Check a container environment. Basically, this is the command Docker exec container ID and env. This is the command for scanning the secrets by using third-party tool TruffleHog. Okay, Docker hyphen image and image name. Basically, we need to make sure to set up a particular third-party tool before using this particular command. Okay, and moving further, there are multiple tools also. Just for namesake, we took those particular tool name. Okay, and moving further, where we are going to discuss how to store and manage secrets safely. Here are the two main methods, and also like it will basically cover some third-party tools or as well as inbuilt options. Okay, coming to the secret managers. So this was some third-party tools or else cloud provider tools we can say. First one was AWS Secret Manager, where uh, it is used for securely storing and accessing the secrets in the AWS workloads. HashiCorp Vault is one of the open source as well as enterprise grade tool, which is help to manage the secrets across the environments. Azure Key Vault, it is also same above purpose for protecting keys, secrets, and certifications, which is used in Microsoft Azure. And coming to these particular tools, which is Docker Secrets, which is one of the inbuilt support for, Docker inbuilt feature support for storing secrets within a Docker swarm. And coming to the Kubernetes secrets, it is a native way to store a sensitive data within a Kubernetes clusters. And the next point was external secret operators. We need to make sure to integrate the cloud secret managers with the Kubernetes for dynamic secret injection. And the best choice was use a dedicated secret manager service that provides a encryption, rotation, and audit trails. We need to make sure to comply with these before we are going to choose any of the like a secret manager tool. Okay, and here we are going to see what is the step-by-step process for injecting secrets securely in a runtime. Okay, earlier slide in the last point we have seen. So that is the point we have clearly going to see here. Step one was we need to make sure to store the secrets in a secret manager. Okay, so the secret managers, whatever we have discussed in the earlier slide, like AWS Secret Manager, HashiCorp Vault, or Azure Vault, or Docker Secrets, like that. We need to make sure to use this for storing the secrets in a secure manner with the encryption mechanism, accessibility, and encryption mechanism, as well as access controls like proper access maintenance. And the next point was we need to make sure to configure your containers to fetch at a startup. That means whenever it is in a runtime. Set up your containers to retrieve the secrets in a dynamic manner, either via the mounted volumes or environment variables or some API calls. It is based upon the how in which method we are going to use secrets. Secrets in which method we are going to manage in a secure manner. And the third point was use some temporary files or memory storage. We need to make sure to avoid writing secrets in a disk. We need to use in-memory storage or ephemeral files that are deleted after it was used, which is basically uses to do not to expose the credentials much. Okay, that is the only reason. The step four was we need to make sure to clean up the secrets when the container stops or whenever the containers restarts. Okay, and the temp files also need to be cleared. We need to make sure such mechanism is implemented. Okay, this is the process to inject a secret securely at the runtime. And here is the Docker Swarm example where which is this particular command used to create a secrets. That means echo, and this is the secret, and a pipe Docker secret create DB password. Okay, and then my password. It was not a secret; it was just a kind of username we can say. Okay, to identify that particular secret. And this is a command used in a service Docker service create. Okay, this was the particular command to use as a service. Okay, use in a Docker service. Docker service create hyphen secret and DB password and container name. Basically, this method keeps the secrets out in the image and inspect them securely at the runtime by using a Docker built-in secret management mechanism. Okay. So moving further to the last slide where we are going to discuss about some best practices and whatever the points we have till now covered, just a kind of recap. Okay. First one was never hardcode secrets in images or code, source code. Secrets should not be like embedded in a Docker file or some source code, or else should not be committed accidentally in your version control. We need to make sure to use some external secret managers or tools to store them. Always use dedicated secret management tools. Tools like AWS Secret Manager, HashiCorp Vault, or Docker Secrets. It will provide some encryption mechanism and access controls and audit logs. Uh, make sure to meet those three criteria. Okay, and rotate the secrets regularly and automate whenever it is possible. Like a frequent rotation reduces the impact of the legal credentials and automate this particular process to avoid human errors and delays. Okay, and monitor for secret exposure with the scanning tools, as we discussed, like a TruffleHog, HashiCorp, like GitLeaks, GitGuardian. This basically these particular scanners will help us to detect the secrets in a code or image or some logs before they get reached into your production as soon as possible in the software development lifecycle. And the final point was train your team on secure practices. That means the team like developers, DevOps team, or security teams should be educated or aware about this particular process, how to handle secrets safely and securely across the software development lifecycle. Okay, and here we are going to discuss these 3 points. This is the last, and first point was secure by default. That means make secrets rotation regularly in a scheduled manner. Sorry. That means a default in the sense whenever we are designing, and in such a way while design itself we need to make sure to defaultly uh, secure. Okay, and the second point was regular rotation, whatever I just spoke, which is regarding uh, make secret rotation in a scheduled manner or automated manner as a part of your infrastructure. That is the one of the best practices. And the third point was where team training we already covered here. It is just like security is not only one team or one person responsibility. It's like a shared responsibility among the like software development life cycle. So educate your team, and like that particular knowledge will basically prevents the leaks before it is actually going to be happen. Okay, so yeah, these are the things I wanted to be discussed in this particular video, and I think so this particular video is helpful, and stay tuned for more videos. Thank you so much for watching the video.